Thank you all for joining us for this month's webinar titled Seal the Deal, Tackling Air Leakage in Metal Building Systems. We appreciate you remaining muted throughout this session. However, it will be interactive, so if you do have a question, feel free to jump in or put it in the chat. I would like to introduce one of our presenters, MBCEA President Robert Tiffin.
Well, thank you, Sasha, and welcome everybody, and thank you for joining us today. So the reason that we're bringing this together is this twofold. One, to bring value back to all of our members on relevant topics. And of course, air leakage is quite relevant, grows more relevant every day. So I'd like to introduce my co-host, one Mr. Vince Sagan, who's the Senior Staff Engineer, and air leakage is very near and dear to his heart. Vince, how many years have you been doing this now with the MBMA and the task force?
I think the project was introduced in 2018. So like a lot of our careers right now, it's pre-COVID and post-COVID. So it's a pre-COVID idea. So we did a lot of the testing during the pandemic, which was a surreal experience.
I can imagine. Perfect. So what I'm going to do is I'm going to turn off my camera for this so we can watch the presentation. And as Sasha alluded to, everyone was muted on their entry in, but Vince and I like conversation. So if you have a question and feel comfortable either typing in the chat or just asking it out loud, we will do best to address you then. We'll limit the answers so that we get through the presentation, but of course can take things offline afterwards. So I'm going to turn off my camera now and jump right into the presentation. So first of all, we should always start with a safety topic because the MBCEA is clearly a safety-focused organization, as well as Silvercoat, where I work. So in today's world with threats of tornadoes, and then if we're from the West Coast, you look at fires, does everyone here have an evacuation checklist? So I found this interesting a couple of years ago. If you're given like the knock on the door by the sheriff's office telling you to evacuate, you've got 5 minutes, what do you grab? Do you know? Do you have it on a list? Here's a couple of things that I would say you should put on your list. And thanks for Vince for the call out, because we all do this. We always forget a charger. Now, if you have 15 minutes, you probably have a bit more time to grab some different things. Now, if you're up to 30 minutes, you can see how the list expands. The takeaway here is, do you have an evacuation checklist for 5 minutes, 15 minutes, 30 minutes, or any amount of time? Do you know where these things are? Can you get you and your family and your things out safely? So thank you for listening to that. So the objectives today are basically threefold and fairly simple. We're not going to get too far into the decimal places with this, but I wanted to address the objectives in the high level. So what and why is air leakage in the energy code? What should you know? And some basic questions to ask. And then what resources are available to you by being a member of the MBCEA, who is a strong collaborator with the MBMA. So first off, what in the world is air leakage anyways? As you can see, there are two definitions, but basically the concept is this. It stems from the residential side of, does your house or your building or your structure leak air? Meaning if you've conditioned it, either warm and or cold, is that leaking to the environment, or is the vice versa, the cold or warm coming back into your building, in essence, wasting energy? That's the whole premise. So why was it involved into the energy code in the first place? Well, it's to deliver meaningful results. So there are 5 listed on the screen, as you can see. So energy efficiency was the one I talked to at the very beginning of, if you're heating or cooling the air or the environment within your structure, but it's leaking out at a tremendous rate, you're wasting money. And to the energy code officials, that's something to be concerned about. Indoor air quality. We talk about drafts. You can find draft dodgers that you've seen out of the marketplace, but really not for commercial buildings. Cost savings, again, you're heating and cooling air that's going out the door or out the window. Why would you want that? Sustainability goals. Clearly, there's carbon generated in creating the energy that you use to heat or cool your structure. Let's try to minimize that. And then, of course, compliance with updated codes. So we're going to get into that. If first we go back to 2009, this is what air leakage entry into the IECC code looked like. 502.4 air leakage. That's what it says. Now let's jump ahead a little bit. to 2012. This was the first incorporation of this. So you'll see in 2012, it changed to C402.4. Again, I alluded to not getting into the decimal places, but you can now start to see all the substructures, sublayers, if you will, of what needs to be tested. So, as with most of the energy codes, there's different compliant options because they want to make sure that they're fair and equitable. So you can either go with, I'm going to build my structure with materials that have a greater air permeability, no greater than 0.004 cubic feet per minute per foot squared. In other words, take a 1 square foot space and puncture that in the side of the wall, and that's the imagery you want to create when you're talking about air leakage. Or if it's not going to be all the materials added up to a number, then it's the assemblies of these materials, but those air leakage rates cannot exceed 0.04. Or, and what we're going to address more today, is the whole building air leakage test results not to exceed the 0.40. So those are the three numbers: 0.004, 0.04, and 0.40. Vince,
And Robert,
go ahead.
oh, I'm sorry. I was just going to add it. I mean, the energy codes started to recognize that you can only fit so much insulation into walls and roofs, and that they had to look at some other strategies to meet energy savings and energy efficiency. So that's why they looked at the air leakage. And I don't know about you, when I grew up, my dad always said, close the doors, close the windows during the winter. I don't want to heat the outside. So it's the same sort of principle.
Well, thank you, Vince. And I love the fact that you were talking to an insulation guy talking about more insulation into a space. We have joked that with the manufacturers, if they would only make like a 4-foot deep purlin, we could fill that space and slow down some of this air leakage, but we know that's not a viable option. So it's a great lift, Vince. Thank you, sir. All right, so this is not an eye chart, but this is, as you can see, the bottom right, it will give the credit to the MBMA and to Vince with regarding what does the comparison of the air leakage testing requirements look like by the IECC ASHRAE 90.1 through the ages, right? The one that we want to look at today is across the top. So if you look at, there's the optional, then it gets into required, you start to see some of the super numbers. I put the QR code up in the top left-hand corner. So if you happen to be on your laptop or on your computer and you want to scan that, it'll actually take you to the article, or if you want to copy and paste later on, this website will take you to the actual PDF document where you can read what all those subset numbers mean. Now you're probably wondering, or you might know, why is Washington and California, or the code of the Corps of Engineers, listed? Well, Washington and California are both states that were early adopters. And as you can see, they were accelerating, particularly Washington, started to require the whole building test earlier than everyone else. And the Corps of Engineers, we're going to talk a little bit about them later on, just to scare you, but also to make sure that you're getting ready. Vince, anything on this chart?
No, again, that's we were trying to, it's a snapshot in time, and we don't have the 2024 code on there, but if it's required in 2021, it's still required in 2024.
Perfect. Thank you, sir. All right, so two of the main ASTM codes that are relevant here, and this is just for your information, are the ASTM E779 and the ASTM E1827. The concept behind an air leakage test in a building is, as you see by the middle bullet point there, of pressurization and depressurization. So the imagery in the background is a blower door test. This is technology leveraged over from the residential learnings of years ago of you pressurize a building. How much air can you pump into that structure? And then how much can you suck out of that structure? And then you calculate the delta, and that is how much air is leaking out of your building. So both of them are the same. There's some nuances to either one we won't get into today, but if you're looking for some light reading, by all means, ASTM E779 or ASTM 1827. So here's the map from energy.gov. And I saw my technical manager, Mike Smith, on here, probably shrugging his shoulders at this point, going, Tiffin, stop going to that site. But anyways, I did. So this is an example from energy.gov of what states have adopted which energy codes. You can see here the dark green, you'll see Washington, you see California, Montana, Minnesota. All the dark greens have adopted the ASHRAE 90.1 2019, or the 2021. So Vince will back me up on this. So Vince, we saw Washington and California has them as required. To some of these other states, are they already requiring blower door tests to be completed and submitted?
If once they adopt the 2021, that's going to be required. And I did get an email from one of our members that Ohio has adopted the IBC 2021, the energy code. And so again, this is always a moving target. And so if you want to know, the other thing that I'll point out is that just because there's a state code, always call your local jurisdiction, local building official, because there could be some local requirements.
So anything like the 2 Dakotas that don't have a state code, they could adopt this whole building air leakage as a requirement. Is that what you're saying, Vince?
Yes, yes. And then the other thing is the owner of the building may want to have meet whole building air leakage testing as well. They may have a special use for their building. Remember interviewing some members to do some air leakage testing, and it was a contractor in New Jersey. He was going to be building a storage facility for Princeton University, and they were going to store art, and they were going to require whole building air leakage testing.
Well, that's cool. So that one of the driving factors then is not always just necessarily code. There are other factors at play, right?
That's right.
Perfect. So just a quick point out, not just the dark green that have already adopted it. These are the folks. So for example, Vince mentioned Ohio, that was at IEC 2018 or the 90.1 2016. These are the states that might be next to adopting. Or what we have found in our experience so far is that a number of the states will leapfrog a 2021 and go to adopt 2024. But as Vince said earlier, if it was in 21, it's going to be in 24. So I put this up here to say, if you're in any one of these states, are you or your customers getting ready for this air leakage test to have to be done? As Vince and I were talking yesterday, he said, well, the code is the law. Now, whether the local building official requires that or not, that underscores the relationship you have with the local building official. But it's in the code, so it's coming. So as the green letters say, are you getting ready? So some of the requirements, as we talked about, there's compliance options, but of course there are exceptions also. You can see a number of them up here right now. I certainly don't expect anybody to memorize that. And if you can identify that, hey, I'm in 3B or I'm in 5C, or you know the zone that you're in, I applaud you for that. But of course, there's easy ways to look that up. One, you can find a map like this. You can see Greenville County identified there. You might pick another state up in Idaho, for example, and look at one of the counties, trying to find out which one you're in. But I'll let you know that this map just changed in 2024. So the fastest way, in my opinion, to find out where your project is going to be is this website. They've just updated it. So I put in Greenville County, where I'm presently located, and we're in zone 3A. Fastest way to find out what the climate zone is for your project. So we've basically covered what and why is air leakage in the energy code. Do you think we've covered that so far, Vince?
I think we got it covered without going too many decimal places.
Perfect. So the next part is, what should you know and questions you could ask? So this is the point where we want to say thank you. We want to say thank you to, first of all, the MBMA, who with the task force led by Vince Sagan, the senior engineer, has driven the idea of metal building systems. How do they do with air leakage testing? So Vince, before I go any further, would you like to give a quick synopsis of the work that the MBMA has done to lead us to this best practices guide?
Well, this best practices guide started again pre-COVID. The idea was, well, the question was, our leadership saw that air leakage testing, whole building air leakage testing was coming. The question was, can metal buildings pass the whole building air leakage test? We didn't know. We didn't have any testing that was done. So he had no experience. And so the project was to test as many buildings that we could, different insulation systems in different climate zones across the United States, and see how well metal buildings could perform. And not with special training, and with just with the existing crews, and with current insulation systems. And we tested a variety of 10 to 12 different buildings, had different insulation systems, from single layer batt insulation to rigid board to spray foam to filled cavity, a whole variety, and different size buildings. Again, climate zones, locations in Massachusetts, North Carolina, Florida, Missouri, Ohio, and Washington State and Minnesota, and some of those great locations during the wintertime. And basically found out that metal buildings can pass the whole building air leakage test. And so had test reports done, and then that information was compiled, and that was the basis for this best practice guide.
Perfect. Thank you, Vince. So as you can see on the right-hand side, there were a couple of other organizations, DASMA, which is the Door and Access Systems Manufacturers Association, and then NAIMA. So it was a collaborative effort, but the fourth leg of this chair, of course, was the MBCEA members. I'd like to call a few of them out now just to say thank you, because they were heavily involved from the proactive side to the learning aspect of it side. So there's Wade Wilson from WC Wilson, who actually helped us with 3 different buildings. And I'll say he was our very first, and where we learned some very critical learnings. We have Doug Stoken from Space Buildings, Kevin Bondmiller of Bondmiller Construction, Justin Arrington of Bradford Building Company, Tucker Cope of C. Tucker Cope and Associates, who helped with 2 buildings, Matt Zellner of Zellner Construction, John Steele from Steelworks Constructions, and Eric Daring from Systems West. So thank you to all of those MBCEA members, and of course to the MBMA, DASMA, NAIMA, and then the individual Bob Zabchik, the Z-Tech Consulting, that collaborated with everybody to pull all that data together to create the best practices to comply with the whole building air leakage testing requirements for metal building systems. And the coolest part for everybody on the call, well, anybody really, is that it's a free guide. I've included the QR code on the screen that you can actually go and download it, or if you don't have that, just Google MBMA best practices air leakage. It'll take you right to the link. By all means, download it and start reading. But we're going to get into it a little bit today. And Sasha, I see some chats popping up. If there's something you want to jump in with, by all means, do so. So one of the critical pieces within this guide are the checklist or the questions. So some of the questions that we learned at the very beginning, if we jump back to 2009, 2018, standing in the cold in North Carolina, was, why are we doing this test, right? Is it to be code compliant? Vince alluded to this a little earlier. Is it the owner's request? Or what we've learned is it to be competitive? I'm going to speak out with regard to Wade Wilson, who's out in North Carolina, has chosen to incorporate this in his projects as a differentiator between himself and other contractors, directors in his marketplace. He's found it to be successful. One of the simple questions that we found in this collaboration, even going right over to with Hall May Builders out in Washington State, is who's going to pay for this test? Vince, do you remember the amount for the approximate cost of a blower door test? Not to be peanut buttered across the US, but do you remember what an approximate cost for, say, a 50,000 square foot building was for a blower door test?
I don't remember those numbers. Because when we got quotes from testing firms to do the test, we actually had some additional services to evaluate different components on the building, like the overhead doors. But
it was a few $1,000s if memory serves. We don't need to get specific, but it was a few $1,000s if memory serves.
Yes, but it's more than a cup of coffee, but less than a new car. How's that?
Sounds like the price is right. Thank you, Vince. Perfect. And the reason I put this up here is who would pay for the test. Some of the iteration of the requirement for blower door test that we learned was, for example, in Washington State, when a blower door test was done in a building and it did not pass the 0.40, there was given a checklist to the contractor or the owner to fix those things, and they were good. Now the requirement is if you fail the test, you must fix all the mistakes or the errors or the places of attention and retest. So now it's certainly more than one cup of coffee, and we might be sneaking up on the size of a car depending on what that car is. So having these conversations or having these questions in your arsenal at the beginning definitely can help you out. So how do we find and hire, or who will find, or how do we find and hire the certified agent? So there's a couple of different ways. There's two. This is on the left-hand side, the Air Barrier Association of America. These are the individuals of the association that actually were the driving force behind blower door tests in the residential world. They've taken this opportunity to become skilled on blower door tests for commercial buildings. Now, you're thinking, well, I'm entrepreneurial, or I'm in a state and I own my market. I'm going to get trained. Well, just to give you an example, this was pulled from their website yesterday. It's a 5-day, all-day comprehensive training. And at the end of $2,580, you can become blower door testing certified. Now, the question I have is, in this code, it says you must be tested by a third party. So I guess the question is, in your market, to your building official, if you do a self-test blower door test, does that count? Just a thought. The other is the NEBB, which stands for the National Environmental Balancing Bureau. The QR code there lists, or you can just look up NEBB, and you can find a certified firm to find an agency that can help you do a blower door test. Or you can call Vince, or you can call Dan Helme. We can help you find somebody in your market that can do a blower door test. What we found out were clearly there were some areas within the building that needed attention. Obviously, this is after the construct, but knowing this ahead of time can definitely help you out. Some would put this into the pre-construction conversation, or when you're looking at the drawings or the listing out, what are some of the areas that you should pay attention to? So dissimilar material interfaces, like the base of wall, we found to be one. I've got some pictures here in a minute to get past the words, but you'll see what we're talking about. Intersections and changes the directions of the air barrier. One of the things that we thought, and as an insulation laminator provider, we thought, oh, okay, well, the overlaps of at the edge of the vapor retarder is going to be a problem. We actually found that's not much of one. It's a lot of the connections, wall to roof, wall to wall, wall to door, and the like. And of course, penetrations. You start cutting through a facing or a vapor retarder and just leaving a gap around an HVA system or a flange brace, you're going to have problems. So let's take a quick look at some of the pictures that we have. So on the left-hand side, and Vince, do you want to talk about this one, about the gymnasium or the athletic building?
Well, the one thing, if we go back to the last slide, the concepts on air barrier and air leakage is not unlike water penetration and water leakage. And so, it's understood that we don't want to have leaks, but we also know that the challenging parts to make a good a building envelope that is resistant to water penetration, you have to pay attention to many of these same details. So penetrations, right? You have to have a good detail, not just for water, but also for air. So if you think water leakage, same concepts really apply for air leakage. The details may look a little different, but it's pretty much the same locations.
Perfect. Thank you, Vince. So leads us to the picture. Did you want to talk a little bit about the dissimilar materials here?
Yeah, the picture on the left is a small athletic facility, metal building. It had a two-layer system. It had a liner system, both in the walls and the roof. And early on, based on with input from our testing firm, who actually was ABAA certified, we actually did tests of the envelope, just of the envelope, without the doors and then with the doors, and we found that the doors were just not specified for air leakage. They were a good door, but this building was not required by code to pass the air leakage test. So we did testing with the doors and without the doors, because the experience is that overhead doors can basically be a major source of air leakage. And what we found was that the building passed, is like 0.20 without the door, but then you threw in the door and it didn't pass the test of 0.4. It was like twice as leakage. So although the door was not designed for air leakage. Now the door on the right, one of the diagnostic tests is the smoke test. So basically, when they synthetic smoke, they fill the interior of the room, or they use wands and they pressurize the inside. Now it looks like there's lots of leakage, but that was a high quality door, and the whole building passed, including with the doors. It was on 0.20. So even though there's an indication of leakage, it doesn't necessarily mean it doesn't pass the test.
Perfect. So you mentioned doors a couple of times, Vince, and with regard to air leakage testing or certification for the door, is the best route then for a builder to suggest buying the top quality roll-up door, or does it a lot involve the door and the proper installation of the door to limit the air leakage?
The answer is yes.
Perfect.
I mean, you can have the perfect door, but if it's not installed correctly, or you don't have the right accessories, it's not going to perform well. So you need to have both. But it doesn't necessarily, again, the question is, when it comes to the door, review the door spec, and that would be a question I would ask. Has this door been selected that takes into account the air leakage? If the architect is specifying the air leakage requirements.
Perfect. Thank you, sir. Now, this is another area of attention, the intersection. So obviously the left-hand picture is the wall to roof. And then on the right-hand side, I've introduced one of the thermal imaging, because is that part of a regular test, Vince, or was that an add-on that we asked our agency to do?
That's a standard diagnostic test that most firms have. And it measures differences in temperature, not necessarily air leakage per se. So the difference in temperature, that picture was taken, I believe, at a building in North Carolina.
This is the athletic facility as well. Yeah.
It was a cold morning, and so basically the difference was you could see that there was a different temperature there because of the transition. The building performed well, but this is an indication that it's tough to maintain that vapor retarder as well as the thickness of the insulation around corners. It's just a challenge.
Correct. So albeit to your point, this is a temperature rating, but one can make the assumption that if the temperature changes, there is some air passing by there, not necessarily alluding that the building's going to fail because of this, but it just underscores the attention to areas like this of intersection between roof and walls, right?
Yes.
Perfect. All right, so a couple canopies and penetrations. We talked a little bit about, particularly on the right-hand side, the HVAC. You can see where it's cut around the outside and not sealed around the ductwork. So that could lead to a significant problem. Not necessarily a failure, but a place to pay attention to, because part of the testing with regard to air leakage in building is now part of the requirement, a visual inspection. So this doesn't necessarily mean the building's going to fail, but it would be definitely an area we should pay attention to. Anything on this slide, Vince?
I would say the one on the right, again, the building performed very well. When we did the test, the contractor basically acknowledged that he didn't have everything completely sealed up. And again, I think that that's important, that you want to make sure that the building envelope is complete before you do the air leakage test. That gives you the best probability of passing the test. I will acknowledge that that can be a challenge. We were working on planning to test one building in Washington State. They needed to have to turn over the building and get the certificate of occupancy on a Saturday, and it was Monday before the glass for the vestibule was going to arrive. So you can imagine it's, that's why you need to have a responsive testing firm and be ready to move and do the testing when the building is ready, and gives you the best probability of success for passing the test.
Perfect. Thank you. So we learned some things, obviously, with the number of different buildings that we tested across different climate zones, with different contractors, with a couple of different testing agencies. One of the key takeaways was, how do we now apply some of these things, and what are the coherent threads? Well, one of them was follow the manufacturer's available instructions, right? Get certified as a contractor or erector to that manufacturer's installation process where it's applicable. And then if there's something that's not quite typical, ask the manufacturer about that. Get their lead in. I alluded to earlier, Mike Smith, our technical director, is on the phone. So call out to the manufacturer, ask them. Some of the examples that we're going to talk about here just quickly are, fiberglass insulation and overhead doors. So if I look at a couple, one obviously with the silver coat and then bay insulation as well, our websites and our salespeople have these at the ready to show you installation instructions of how to play that out. If there's something specific in your building that doesn't quite work with this, reach out to the manufacturer. The same thing with overhead doors. There are available detailed drawings, interpretation of detailed drawings. I understand that can happen. Reach out to somebody, reach out to the salesperson, reach out to the company themselves, or reach out to the MBMA, who happens to also be neighbors, or if not in-house neighbors, with DASMA. Just make the call, ask the questions. Would you agree with that, Vince?
Yes, and the other thing would be is don't be afraid to reach out to the metal building manufacturer that is providing the building, because there are certain situations where if they could provide a supplemental piece of steel at a transition, for example, from the roof to the wall, it's a lot easier to make a seal when you're pressing against the solid piece of steel for that transition than trying to do that against air. So metal building manufacturers would be happy to work with you, and they'd be happy to sell you more steel.
Absolutely. Well done, Vince. Well done. So if we look at some of the things in the prep for the test day, so applying some of the things we've asked, we've done some learnings. So I put this one up here, and some of you are probably going, utilities present, power lighting. Well, it seems kind of obvious. Well, as I alluded to, our very first test up in North Carolina, it was just a freestanding building. We went to hook it up, and there was no power to the building. So we went and got generators. Thought we'd be done with that. Nope. Because of the sensitivity of the equipment that the agency that we were using to do the testing, we then had to go get inverters. So I'm looking for sympathy here, everyone, for Vince and I. It was a cold North Carolina morning. Now, it was beautiful, sky was blue, but cold morning, getting equipment before we even started. So we wanted to make sure that we're sharing this with you, that yes, you should make sure that the utilities are present before you start. Obviously, a lift on site for sealing some of the penetrations. We can talk about the exterior, the environmental conditions. Your agency, when you're working with them, will ask you or will tell you, and they will help govern this. Because clearly, part of the testing procedure, if it's a high wind day, probably not the best to do the test. So constant communication with your agency is required or is very helpful. And then building activity. Vince talked about the one in Washington. Well, we did another building on this same location up in North Carolina, and the trades were trying to walk in and out the door. So as you can imagine, trying to do an air leakage test where you're pressurizing or depressurizing a building and the doors are constantly being opened, it kind of leads to a fail. some of the
Yeah,
things.
the other thing, Robert, I'll
Yep.
just, if you go back to the back slide, have. So for ceiling penetrations, now the penetrations we're referring to are penetrations that are intentional. For example, ducts, for the HVAC, plumbing. And so this is where an experienced testing firm will basically take the lead and know what things to be sealed and what things should remain open. And so, for instance, all the plumbing traps should be filled with water. Certain air ducts should be sealed because that is intentional, and you should not be penalized for, designed openings in your wall envelope. A detail, but again, an experienced testing firm will know what to do.
Perfect. So some of the things you just touched on, Vince, are on this screen here, to what the experience and why you want to make sure you have a good partnership with the testing firm, because they'll make sure that you're getting the best shot, or your building is getting the best shot at, as it says down there, when they provide the report, did your building pass or did it fail? And that can either cost you money or cost you time. So the better preparation, the better off you'll be. So ultimately, what does a report look like? So this is an example. So High Performance Building Solutions was the agency we used on the East Coast, and they will give you back a comprehensive report. So we're not going to go through this through detail, but just to show you quickly, it was a 30-page report listing a number of different things, with call outs, with pictures, as you can see here, with charts, with information that was critical to their findings to substantiate that A, this building passed, where, and then some points of interest for the next time. So when you are talking to your agency, when you're talking to your owner of the company, this is the report that you're going to talk about, and you can pull some key points. But clearly, any exercise, anything like this, really comes down to, so did we pass or did we fail? So we look at this one in particular. This was Camp Bow Wow up in Swansea, Massachusetts, and I've highlighted the test results. So Vince, simple question: did the building pass or did the building fail?
Well, that's a trick question, Robert, because this building wasn't required by the building code to pass an air leakage test. However, if we were using the 0.40 limit, that would have passed.
Perfect. Now, just to throw this in here for some folks, and we don't have a slide on, but I want to talk about it, because way back when we had that chart up there, we had the COE, the Corps of Engineers. So presently for whole building leakage, it's 0.40. Vince, what do the Corps of Engineers test their buildings at?
I believe it's 0.25.
So would this building, albeit not required, would this building have passed 0.25 for the Corps of Engineer testing?
I would have to do the math, and also it depends on whether you take the average of both values, or you look at both values, but it's close.
It's close.
It's close.
So,
and this was one building that didn't have all the penetration. The building envelope wasn't complete. So if I was a betting man, which in some ways I am, I would say that this would have passed the Army Corps of Engineers test.
Perfect. So
I'll also say, if it was in Washington State, where it is currently 0.25, it probably would have passed as well.
Perfect. So just to reiterate what you just said for the folks on the phone. So Washington State was an early adopter of the 0.40, but now they're 0.25. So do we see that trend? Like, so 2024 has got the whole, but it's still at 0.40, but we can assume, based on experience, that codes will continue to get more aggressive and likely will go from 0.40 to 0.25 at some point in the future. Would you agree with that sort of generalized logic?
No, that's the plan. The plan was, let's first introduce whole building air leakage tests. Let's select a value that we feel that most buildings can pass. And then we start making it more challenging to pass that test.
Exactly. Now, I've heard rumors, Vince, just to freak people out here on a Thursday afternoon. So the Corps of Engineers, Washington State's 0.25. I've heard another number for the Corps of Engineers that they're testing. Do you want me to share it?
What, 0.15?
The 0.15? So 0.15. So we have a little bit of work to do to go from 0.40 to 0.25 to 0.15. But the good news is that everyone involved from MBMA to MBCEA to NAIMA to DASMA are actively working on this, along with the metal building manufacturers and component and material supply are working on this to get us there. No one's alone in their field, right? But all of our ultimate goal, and I'm quoting Vince from a number of different presentations from 2 years ago, our whole objective is to pass the test, right? Perfect. All right, so we covered what and why is the air leakage energy code, what should you know, some questions to ask, resources available. People, you're like, hey, Tiffin, you just said resources. Well, people are resources. As you've heard the call outs today, this was a collaborative effort with a number of different agencies and a lot of people. A great way to get an answer to your question with regard to, hey, I'm going to try this or I should try that. The one person I didn't put on this here was your local building official. But before you call them, feel free to call any one of these folks. Reach out to them. If you don't have their contact information, you can reach back to, Dan Helme is the chair of the MBCEA Technical Committee. You can send Sasha a note. You can call me. We'll get you connected to help to try to shorten the learning curve, if you will, of whole building testing or air leakage in general. If you're really not a people person and you want to research things, I listed all of the links that I used, that Vince and I have used over the last number of years to create these presentations, the conversational pieces, the scary parts about the 0.40 to the 0.15. Sasha's recorded this. It'll be available in the members area of the MBCEA website. So you can go back there and pull all of these links together. So we covered the objectives for today. So the question to you is, are you getting ready now? And I'll just say thank you, everybody, for the pleasure of your time and the privilege of your time. And I saw there was a number of things in the chat. So Vince, do we have a couple of minutes for questions?
I'm ready.
So actually, that was me dropping links in to the different resources, but
Oh, good.
yes, please either type in the chat or just come off of mute and feel free to ask your questions now.
Well, I would like to add that whether it's required by the code or not right now, and you haven't experienced the whole building air leakage test, it wouldn't hurt to engage a testing firm and test the building. Maybe it's your own building that you're constructing for yourself and see how well it performs. When we were doing testing for several contractors, they would actually bring out their crews to actually observe the testing, and they were able to ask questions. They could see how important certain aspects were. For example, a building down in Florida, when they saw smoke coming from underneath the wall, at the base of the wall, the superintendent basically said, I would never have considered that to be an issue. So, just a thought.
So a question to you, Vince. Does the task force of the MBMA have plans for or needs for additional building types in different climate zones, or do you think we have enough information with regard to putting together the best practices guide?
Right now, we don't have any plans to do any more testing. And we did climate zones from Florida to Massachusetts through Ohio, Minnesota, and Washington State. We felt that we kind of covered, and including Missouri. We didn't do the desert Southwest. but we don't feel that that's important. I mean, if someone would like their building in Hawaii to be tested, I may consider that, but right now we don't have any plans to do additional testing. Right now, it's going to happen, and we feel like we have the resources. MBMA does have a project to take the energy guide that's basically a document and create some videos that could help to supplement it. So we're in the process of working on that, and we're hope to get those online very soon.
Perfect. So what you're saying is that for early notification, that if folks went on to the MBMA Education YouTube channel and subscribe, that they'll be notified when that video is done, right?
That's correct. And we will be reaching out to some of our members, some of your members, to help us with those videos. We're working on the scripts. Once we get the scripts ready, then we actually want to film actual construction of some of these details. And so that can be shared with, and the whole idea is to have this resource available to you. Again, the goal to pass the test. Because the last thing we all want is have a building that passes gas. Oh, sorry.
Well done, Vince. Well done. So that's it from Vince and I, Sasha. If no one's got any questions, then we can.
I do have a question.
Oh,
I don't know if you're hearing me.
Yes, sir, we can.
Okay. At one point, Vince was saying something about the roof to wall transition, and that on a thermo camera where it shows red in that area, he was saying it is not exactly an indication of air transfer, but that intersection can be harder to insulate, and it's just showing heat in that section, not necessarily air transfer. But then right after Vince said that, you said something else about, I thought, if I heard you right, you said something else about, so that does show indication of air infiltration. And then I thought, Vincent, you agreed that that was right. So I'm confused on that detail.
So we can go in reverse order. So what I was saying is that it could not, it's not a direct correlation, right?
Okay.
If there is attention that thermal imaging that I just put it back up on the screen shows is that you should pay attention to this area, and B, that there might be air passing in between the transition between the roof and the walls.
Okay. All right. I guess I just didn't catch the could be detail. And I'm actually dealing with a similar situation right now, which is why I'm here today. I'm trying to learn a little bit more. We had a thermo scan done on a building, and it looked just like your picture. We're thinking that the seal is tight and there is no air moving through, but I need to be able to explain that to the end user. And so when you spoke on that detail, it was relevant to what I'm working on right now. So I understand it's potentially can look red anyway because of a difficulty in insulating that intersection. But
Correct.
You're also saying it can also be an indicator of air transfer.
Correct.
That is
Okay.
That is correct. And
All right.
I'll just add that just because someone owns a thermography camera, it doesn't necessarily mean they know how to use it or interpret the results correctly.
Oh, no, this was done by a professional company.
Okay.
And then we received the report from them. So we're working to detail this further. So, yeah, but you've answered my question. That's all I had for you. I appreciate it.
Thank you, Richard. Appreciate it.
Thank
I have
you.
a question.
Yes, sir.
So based on what we're seeing here in your best practices guide, it seems like blanket systems need to be upfitted to a liner type condition around corners, eaves, transitions, penetrations of all kinds. Assuming that is correct and based on Skyliner or Silvercoat system, being fall protection once that liner is installed, and based on how much better a liner building looks because of panel deflection and additional oil canning because of tension over a blanket. I mean, if someone is looking for this spec, or is it not just to be assumed you're better off to go to a liner system?
So I know we've got two individuals on the phone that could, from the insulation world, or a couple of people. I saw Mike Smith on there. If he wants to talk first, then we can have the old, I'm aging myself here, the point counterpoint from Bill Beals. Mike, do you want to respond to Jason's question? Or if not, then we can have Bill Beals answer Jason's question.
Can you hear me?
Yes, sir, we can.
All right, so the answer is not necessarily. Liner systems aren't, the only way to go to achieve the results that we have here. We have done pinched draped insulation in many cases prior to this testing that was done, and they perform very well. The problem is the codes today have kind of driven us to the liner systems. That's why the focus was more towards those and filled cavity systems. And the only exception would be semi-heated space, to which pinched insulation could be used, but semi-heated space is exempt from the provisions of the air barrier requirements. So that's kind of, we were looking ahead to see, code compliant insulation for a metal building in all these climate zones typically are liner systems, and they can be a little more difficult than the old 1/6-inch tab, with the sealed tape, wrap your corners, and those were quite actually easier to pass.
Well, we did one build, just to add on the bill, his comments, is that we tested one building in Florida. It was, I think they call it a Sagan bag. So it was actually 2 layers of insulation blankets. And that performed very well. I mean, it basically, it would have even met the new Army Corps of Engineers. We basically, the air leakage was 0.10. It was a good installation, and it also was a gym and didn't have many openings or penetrations and not many windows. So it was installed well, and and it performed well.
So was that using the continuous air barrier that had insulation packed inside the cavity and the tape like you show in the best practices guide, or was that just a regular blanket insulation building?
It was not a filled cavity. It was basically, you could see the purlins, and it was draped in between.
No. I'm saying in your guide that you made, it shows different images that show a continuous air barrier going from the vinyl facing to the jamb, for example, and being taped, or a continuous air barrier going from the vinyl facing around a roof to wall transition that has like an open lean-to, and that being packed and then covered with a continuous air barrier and taped. So your guide shows a continuous air barrier. So what I'm asking is, was that just a regular blanket building that didn't have those continuous air barrier treatments? And does that mean to achieve this air permeability, you really just need to install this stuff correctly?
I think 2 things. One is to pass, basically the code says you need a continuous air barrier, period.
Sure.
Regardless if you take the option for passing the test or not, you have to have a continuous air barrier.
Okay.
And you can achieve that with different insulation systems.
Sure.
The thing is, with our guide, we were trying to keep it as short as possible and try to address a variety of situations. We couldn't cover all the insulation systems out there. The idea is, it's a guide, gives you some information. It tells you, gives you things to look for, and gives you some suggestions on how to deal with it, and gives you a nice little checklist, but it's not comprehensive. There's just too many systems out there. And I would say, Bill, you've got a dozen different systems that could, and maybe 3 or 4 of them could meet a particular need. It just depends what's best, and it's what's selected by the design professional. So we couldn't cover them all.
All right, and just to back up on the air barrier requirement and how it's written, You know, technically you have to identify the air barrier. It can be the vapor barrier, or it can be any combination of materials from the inside to the outside of the envelope, as long as they're joined and continuous throughout the envelope. So if you take a piece of facing at the top of the wall and wrap it up over the eave strut, peel the insulation away and wrap it, then you've made a continuous seal there. It may not be, you know, what people were doing 5 years ago, but it's a simple format to do, to maintain the way it's written and assure that there won't be any leakages. Double face tapes become part of the air barrier, because once you mash the facing into a double face tape, put your screws in, that seal is not going to break. So even though we assume the air vapor barrier is going to act as, it's also a combination of other materials as well that we rely on at the transitions, especially. So
We actually tested a building that relied on a metal liner panel on the interior as their barrier, and the building performed very well.
Okay.
Well, thank you, Jason. Thank you. And I know Mike was experiencing difficulties. Mike, did you want to, now that you found a way with the mic, did you want to say anything in particular, or did, go ahead?
I mean, it's when it comes to, you know, the air sealing, multiple layers is always good. You have deep, you know, you have infiltration and exfiltration. So, you know, depending on where your vapor barrier is located in the system, you know, it might be something that the metal building manufacturers are looking at. I know a lot of them have options for, you know, sealing the exterior panels, but having 2 layers, especially one to the exterior of the envelope, it would just go a long way to making sure that that cavity stays dry and air sealed. So, I mean, a combination of a vapor retarder on the interior and sealed, you know, weather stripped, you know, panels on the exterior, you know, would probably go a long way to meeting that new Army Corps, you know, rating as it comes down the line.
Beautiful. Well, this has been fabulous. Thank you. And I would say the takeaway is, so Sasha has recorded this. She'll put it in the members area for people to download it. If you have any questions as you're, you know, walking around today or tomorrow and have a question that's popped up, by all means, reach out to us. We're here as an industry to help, because clearly the transition from blower door test and air leakage in a residence is completely different than a commercial or metal building system. And then the other takeaway is, please subscribe to the MBCEA YouTube site, the MBMA YouTube site, and everyone join me in thanking Vince Sagan, Senior Staff Engineer for the MBMA, for his expertise today. So thank you for your time. It's been a privilege, and have yourself a safe and great rest of the day.
Thank you.
Thank you.
Thank you, Robert.
Thank you.